So here we have another example of a word problem, fairly contrived because somehow we know this model that puts the value of a copier in context with how many years after it was purchased. But nevertheless, we need to first graph this equation. So the very first thing, I know that M is negative 600. B is 4,000. And again, because of these quantities, I'm going to scale my graph. On the y-axis, I'm going to count by thousands. So this is 4,000, and there's my y-intercept. My slope is negative 600. That means my y values decrease by 600 every time my x values increase by 1. Just pay attention to the units. The y values are that is a value, so probably dollars. And the x-axis is years. So this is rate and it's dollars per year. Since I'm at 4,000 and I need to go down 600, I know I will be at 3,400, right? Again, I'm just estimating roughly where it is. And to repeat, I'm at 3,400. I'm going to go down 600, so I'll be at 2,800 and 1 to the right. And there's a rough sketch of my graph. Real rough. B, what do the y-intercept and slope represent in this situation? Well, the y-intercept, 4,000, is the original price of copier, because the y-intercept occurs when the x value is 0, or when no years had passed. The copier was $4,000. That's the original price of the copier in dollars. And what's the slope? Well, as we talked about, it's a rate because the units of it would be dollars over years. So it is the rate of decrease, because it's negative, of the price of the copier, dollars per year. Finally, use the graph to estimate the value of the copier after 5 years. This one I might actually be able to do. So I'm at 2,800 after 2 years. So 3 years later, I'm going to go down another 1,800 units. So from 28 minus 1,800 will be 1,000. Based on my graph and some simple calculations, I expect the copier about $1,000.